And let's do attendance. So tell me that you're here, and then we can get started with a programming lecture. So please get idle open up and ready if you'd like to follow along. Reinstall it if it needs to be reinstalled. But we are going to do Python stuff today. We're going to talk about loops and lists. So finally, we're going to make a program that is capable of looking like this. Do something, do another thing, go back to the first thing, and repeat. That's going to be nice. That'll make it a lot easier to draw that, all those squares that I was trying to draw last time, right? That will be beautiful. So, I want to make a pit stop first with errors, because errors can happen. We can make bad programs, can't we? We've made bad programs in Scratch, but Scratch programs just kind of let us do whatever, and they don't really complain. You can get into like an infinite loop in Scratch, but that's about it. It's not going to complain to you like, oh, you put a string in an int and I'm not happy. It's going to figure it out. So more things can go wrong in Python. Let's talk about some of those things. There are two main kinds of errors in Python, okay? The new main one that is not really existent in Scratch is runtime errors, okay? And that just means it's an error that is so bad, it's unrecoverable, and it happens as your program's running. So Python can't figure out that something bad's going to happen before it runs, so it tries to run your program, but something went wrong, and it has to stop the program. It's like, I give up. This makes no sense. I can't continue. Okay? So the program will end after a runtime error occurs. So the easiest example of a runtime error is division by 0. That's undefined, right? So let me just quickly show that to you. Let's figure out what lecture we are in today. We are lecture 19, it seems. So let's save this in the right spot. Runtime error.py. So, I don't know. Let's make it slightly interesting. Let's be like n equals, let's ask the user for something, input, enter a number, and we're going to get that number, convert it to an integer, because we want to do some number stuff, and then we'll be like print n divided by, I don't know, or 42, how about that? 42 divided by your number n is, and then we're going to calculate it, 42 divided by n, whatever that happens to be. So that seems like a nice, benign program, right? So let's run it. Let's try and make it small on one side so that you can see the rest over here. Enter a number. Okay. Enter a number like 2. Sure. 42 divided by 2 is 21. Awesome. That's not bad. That makes sense. That worked. But if I run it and I type 0, enter a number 0, oh no, we get red text. It's usually very helpful. It's like on line 2. So this line right here had a problem. It's like this line, something bad happened. The bad thing was called a 0 division error, and the textual information to go along with that was division by 0. So that's a runtime error. The program stopped. It wouldn't go any farther. Like maybe I can print something after that just to show you that. Like enter number 2, prints it, prints hello. That's the next thing. But if I type 0 and the runtime error occurs, it stops the program. Okay, it does not continue to the next line. Okay, that's what happens. You'll see red. It should be very helpful. Say where the line, what line was the issue, and what went wrong, and then it's your job to fix it. Okay, that's a new kind of thing that can happen when you're writing Python code. The other kind of error is very subtle, can also exist in Scratch, of course. It's called a logic error, or a bug. You might know it by that term. That's the more colloquial terminology for a logic error. So that just means like your program is going to work, it's going to run, it's not going to like stop itself or anything. It's just you meant to do something, but you didn't do that something. You did something else accidentally. That's what a bug means. So here is, I don't have to write a program, I just write it on the slide. This is a very easy example of a bug, right? Let's set I equal to 42, and then let's make an I plus 2 variable, call it exactly this, and set it equal to I plus 1. That is a bug, right? That's a logic error. I think anybody who is naming their variable this expects it to hold 44, but it's going to hold 43. That is incorrect. So that's a simple example of a bug. Okay? Any questions about this terminology? Just new stuff, or re-explaining stuff you might already know. So yeah, that's errors. And now that we know about them, I'm ready for lists and loops. So the first thing I want to talk about is lists. It's a way to hold a bunch of stuff at once in Python. That's quite nice to have. Okay, so let me show this to you. A list allows you to hold several things at once, because right now we're kind of forced. If we wanted to store like the coordinates of a point, like let's pretend we wanted to store 3D coordinates, like the point 235 is my example apparently, 235. So 2, 3, boop, boop, and then 1, 2, 3, 4, 5. So go out, go out, go out, go up. That point, if we wanted to store that in a computer, maybe we'd have to make 3 different variables, right? An x variable holding 2. Right now, we'd have to make a y variable holding 3 and a z variable holding 5, which is kind of unfortunate. We would like to keep the whole thing all together. I hope you can agree with that. Lists allow us to do it. Lists allow you to put a bunch of stuff in between square brackets, and everything is saved all in order. So I can say something like this instead. Let's make a P for point and let it hold 2, 3, 5 in that order. And then P, the whole thing, like in its box, it holds the list 2, 3, 5. And so it's got all the points in one spot, and that's kind of useful if we want to store a bunch of them. Okay, so that's what a list does, and that's the syntax. And you kind of read it like this. This is the list holding 1, 2, 3 in order, where 1 is the first thing, 2 is the second thing, 3 is the third thing. This is like, this list is not equal to the list like 2, 1, 3, for example. The order really matters. Okay, and yeah, a list is just a single thing with a bunch of stuff in it. You can assign all that stuff into one single variable, like P. Okay, so that is list. Let me give you a program example of that. Lists.py. Of course, I've lost where to save it. Maybe if I press new from here, it'll save it in the right spot. Yeah. Lists.py. So I can say P equals 2, 3, 5. I can print P, just that by itself, it remembers. Like, okay, that's the whole list. Storing all of those 3 numbers in one spot. That's what a list does. And yeah, I think we're ready to do fancier things with it. Okay, so I hope you understand like the importance of this. It's just it's like a one-stop shop to hold a bunch of stuff that is useful, like a point, or like all the numbers that the user enters, put them all in one place. You can build lists in a bunch of different ways. You can make them, of course, by giving all the values you want explicitly in order, or you can make lists from scratch if you would like. You can start from the empty list, which is just 2 brackets right next to each other, and then you can add lists together with the plus operator. So you can do something like this. You can say, I have the list 1, 2, I want to add it to the list 3, 4, and that will give you back the bigger list, 1, 2, 3, 4. It adds them together. That's what list addition is. Let's do it on the REPL. Plus 3, 4. And so that gives me back one big list. And so that's how you can build stuff up. You can start from the empty list and then add a list with just 1 in it, plus a list with just 2 in it. And that makes the list 1, 2. That's not too bad, I hope. So yeah, that's how you can build lists if you would like. Use the plus operator to make bigger lists out of smaller ones. Empty list is just two brackets right next to each other. One thing you usually want to know about a list is how many things are in it. There's a len function built into Python that tells you that. Okay, so if you ask for the len, the length of the list 1, 2, Python will give back the number 2 because there's 2 things in that list, right? So if I do it for my p, and say print len p, there are 3 things in p, so it's going to print the number 3. That'll do it. Any questions about that new syntax? If you have programmed before and you're coming from like C++ or something, this should make you very uneasy, but it's totally fine in Python. 2 high, 3.14, not a problem. You can put multiple different types of things inside a list, a single list. Let's see here. Yeah, I think that's everything I wanted to say on this slide. So, once you put stuff into a list, it would be nice to get those pieces back out. Let me show you how to do that. You are able to access or change even individual pieces of any list. And we use things called indices to do that, okay? So let me show you what the indices look like. Let's make a list called X, for example, with 1, 2, and 3 in it. Or you know what, to not confuse you about the indices, let's make it hold like 5, 6, and 7. How about that? So those are the 3 numbers that the list X will hold. And so really secretly in memory, it kind of looks like this. It's got those 3 things, 5, 6, 7. And that's the list called X. And 5 is the first thing, and it has an index called 0. Okay? The first thing in a list is the 0th thing. Because we're computer scientists, we like to start at 0. 0, 1, 2. So the index of the 0th thing, or the first thing on the list is index 0. The second thing on the list is index 1, always, no matter the list. The third thing on the list is index 2. Okay, so if you want to get the first thing out of a list, you want to access the 0th index of it. Okay, so technically the second thing is like the 1th index, let's say. And this is how you do it. You use those same angle brackets just with the index that you want, okay? So this is the syntax. You say X, I want the 0th thing out of X. You put brackets just like that, and you say, this is the index. Get me that index, please. And that will give back the 5. If I ask for the thing at index 2, it'll give me back the 7, okay? That's what that does. So let me just show that to you. We can print P of 0. That should print the 2, right? Sure, save. So that prints the 2. Print P of 2, right? That's not the second thing. It's really the third thing because the indices start at 0. So that prints the 5. That's index 0, 1, 2 in this list. Okay, so that's indices starting at 0. Surprisingly, you can also use backwards indices that are negative. So if you want the last thing in a list, you don't have to care about how big it is. The last index is -1, okay? So that's quite easy to remember. Every element of the list, that means it has 2 valid indices, starting either a positive or 0 number and a negative number starting from the end. So really this is -1, -2, and -3 as well. Hopefully that makes enough sense. So yeah, if I ask for X of -1, that will also give me the 7 here. If I ask for X of -2, that'll get me the second to last thing. That'll give me the 6. Okay? That's how that works. So you can also use negative indices. So let's do print P of -2. So the second to last thing in this list is 3. That'll print the 3. All right? So that is lists and indices. You can get stuff out of it. You can also set stuff. So let's say that I want the x-coordinate of my point to not be 2 anymore, but to be like 7. I can say, okay, P of 0, treat it like a variable. Set it, please, to 7. I can set that as well, that certain thing at that index. And now the entire list has changed, right? It now starts with 7. Okay, so I can change things as well. Okay, so that is that. Slightly better. Any questions on this? Doing cool stuff with lists. All right, and I think if we're good to move on. I would like to get into the meat of today, which is loops. But first, I think I have a question. So let me ask you this question right now. So please, I guess, why not? Go to the Written Nice page. Let's give you some time to try it. As a group, as a peer instruction group, get together and think about these indices. Let me clear it out just quickly. Write down as a group 2 different ways to get the 5 out of this list L. See if you guys can figure it out. So I want to extract this 5, like I want to print it somehow. Something involving L, because that's the name of the list, right? What do I put in the blanks to print 5? There should be 2 different ways to do it. So you tell me, all right? Try not to cheat and look at the people who have already written in the page. But yeah, take a couple minutes to figure out how you would print 5 using L. All right, take about 30 more seconds to get something written down. All right. What did we come up with? Thank you for humoring me. 3, -4. Do we all agree on that? 3. Let's see. Indices time. So we got index 0, 1, 2, 3. Okay, so it's positive 3. And negative what? Negative 1, negative 2, negative 3, negative 4. Goes all the way to negative 5, negative 6, and negative 7 if you really wanted to. So those are the 2 different indices for each element in the list. Yeah, so 3 and negative 4. Very nice. So it'd be like print L of 3, please. Or print L of negative 4. Either one would work. Any questions about that? Not too horrible. Okay. So, yeah, if we're doing okay, I think we're ready for loops. Let us begin. So the idea of a loop, right, is to, I wish it would let me click that. The idea of a loop is to have code that comes back around on itself and repeats. Okay, there's like a loop going on now. So what we did before was we had a loop block, right? Like while or like forever, do this stuff in Scratch. And all the stuff that we wanted to repeat, we put inside of that block. So just like for turning if blocks into if statements, it's going to look something like this. You're going to say something involving a repetition sounding word, and then you're going to have a colon, and then you're going to indent, and you're going to put all the stuff that you want to have repeated, right, on the indented block. That's essentially how it's going to translate all over again. All right, so that is the syntax that we're about to learn, one of them at least. So you totally know all this stuff, right? So we just have to figure out what it looks like in Python. So just like in Scratch, a loop repeats things. It repeats one line of code, 2 lines of code, whatever you want to put in that thing called the body of the loop, okay? And that's the stuff that gets repeated. And as usual, you're allowed to control the repetition. You can say, I want this thing to happen forever until the end of time. I want it to happen exactly 13 times, no more, no less. You can do stuff like that, okay? So yeah, in Python, the standard name of a loop is called a while loop, okay? And so we had one of those blocks. We had like a while block, or maybe it was like repeat until. That's kind of the analog of the while loop, okay? That's what's going to happen. So yeah, a while loop, I'll show you how to write it, but what it does is it executes its body as long as its condition is true. Okay, so here is how it will look in block form. So we're going to have some kind of condition that is a Boolean expression, something that gives back true or false, condition. And so long as this condition is true, evaluates to true, we run the body of the loop. Okay, as many things as we want to put in here. The body could be a million lines, could be just 2. And then we go back and recheck the condition, because maybe it's false now. Okay, but as long as the condition remains true, like x is greater than 7 still, we're going to repeat the body. That's going to drive the way our loop runs. And then eventually, the condition should become false. If you have a non-forever loop, like a loop that doesn't repeat forever, once it becomes false, the loop is over with. It's like, okay, it's only repeating the body if it's true. Once it's false, we stop the loop and continue with the rest of the code. So that is how it works in diagram form. And now let me show you it in actual text form. Let's see what it looks like. Okay, so it's very, very similar to the if statements, if, else, elif stuff. The only difference is that the body can be re-executed because it's a loop. Okay, so yeah, let me draw what a while loop will look like in Python. So you say while, you say the word while, and then you put your condition, just like for an if statement. Goes right there. And then you put a colon, and then you tab over, or put a couple spaces, something that differentiates the body from the rest of the code. And then here's your body. This is the body of the while loop. Could be as many lines as you want, as long as they're all at that same indentation level. And then you go back out, and this is the rest of your code down here unindented. Okay, so that's what a while loop looks like. And here's how it works, just like this. It first tests this condition and sees if it's true. And as long as that condition is true, it executes the body and repeats, rechecking the condition each time before it repeats the body. Okay, and then once this condition becomes false, it evaluates to false. X is no longer greater than 7, for example, then you're finished with the loop. Then it does the rest of the code down here. It's done with its repetition. Okay, so interesting. Something that we can do in Python is make a forever loop. How can we make a loop that never stops executing its body? Well, we need a condition that's always true. What's the simplest Boolean statement that is always true? True itself. So we can say while true. Surely true will never be false. So we can just say this, and then all the stuff in here always gets executed until like you press the X and stop the program yourself. Oops, executed. So that is an infinite loop, a forever loop in Python. Let me show you that infinite forever loop. Forever loop.py. So let's just be like, I don't know, while true, please print hello world or something. So this is going to print hello world until the end of time, and like this code will never get to it. We'll never get here. Because this is outside of the loop, right? Only if it were to stop would we execute this code, and it's never going to stop, right? So let's run this. Whee! There it goes. And one way to stop a program that has an infinite loop that is accidental, besides pressing like the X or something, you can type Control-C on the keyboard. Control-C just sends a special, it's called a keyboard interrupt to the program, and that stops it for you too. Okay? But when in doubt, just click the X, it'll stop. So, yeah, that stops a runaway program with an infinite loop. So, yeah, that is the first example of a while loop. Any questions at this point about the syntax, what's going on? Mm-hmm. So when you do like Control-C, does it like force the program to like take an error message? Yes. You know how to program, so let me say that at a lower level. What's going on is it's sending I think it's an exception. A keyboard interrupt is maybe a form of an exception, and you're actually able to catch that if you would like in the program. So it doesn't have to stop, but the fact that I didn't have some handler set up for a keyboard interrupt means that it gives up. Mm-hmm. That's right. So it doesn't have to stop the program, but you have to do some special stuff in order to set it up to continue. Yeah, any other questions? Okay, so yeah, that's one kind of loop. Let's do loops that actually stop. Now, let's talk about iteration. Let's go through something like a list of numbers or just the numbers 1 to 10, let's say. Let's print the numbers. This is my example. Let's print the numbers from 1 to 10 in order. And let's see. So before we knew about loops, we would have to say something like this. We'd have to write the code. Print 1, new line, print 2, print 3. That's no fun. That's repetition. That is like cheating, right? That's no fun. We don't like that. So what do we want to do instead? Well, let us make some kind of loop that runs the same code in its body, but yet that code somehow prints a different number each time it runs. At first it prints the 1, then it prints the 2, then it prints the 3. So the trick, the way to do that is to use a variable. Use a variable to hold the thing you want to print right now, and then maybe change that value so that the next time you come around and do that same code again, you'll be ready to print the next value. Okay? So usually because we're doing something called iteration, we're going through some numbers, we use the variable I for iteration. So here's what I would like to do instead. Let's make a variable called I, started at 1, and then repeatedly, here's the idea, repeatedly, this is not correct Python, but you get the idea, repeatedly print I. So the first time it'll print the 1, right? And then increment I. You see how these two lines of code, when repeated, will print new things each time? Because I is changing. So then increment I, that makes I 2, and the next time we come back to the print I is a different number, and it prints the 2. And then we increment it to 3. And then the next time we come back to repeat the print I line, now we're printing 3. Isn't that cool? So we just want it to keep going like that, and eventually, like it'll get to 10, we'll print the 10, and then we'll increment it to 11, but we don't want to print 11, right? We want it to stop. We want the loop to be done at that point so it doesn't accidentally print 11 because we only want to go from 1 to 10. So our goal is, let's start our I at 1 and print that I and increment it also as long as, while I is less than or equal to 10. That is a condition that tells us when we would like to keep printing that I value. Okay? Did those words make sense before I translate that to code? This is exactly the condition we need here, because I is starting at 1. We want to keep on doing stuff while that I value is less than or equal to 10, because then it will be a number that we care about printing. All right. So, let's see. I guess let's just go to code. What do I want to do? Let's just say loops. Loops.py. Okay, so here's what I want to do. I would like to make a variable called I, started at 1. That's the first value I want to print, right? And then while I is less than or equal to 10, I would like to do the following. I'd like to print the current value of I. So right now, in the first time, it's 1. And then I want to increment I. I equals whatever it was plus 1. Okay, that'll make it 2 and 3 and 4. It'll always add 1 to it, increment it. And so repeating this code will eventually cause I to get large. It'll cause I to get to 10, right? And so when I is 10, hey, is 10 less than or equal to 10? Yeah, that's still true. We'll print our 10. We'll make I 11, and that'll stop the loop, because is 11 less than or equal to 10? No, that's a false statement. So that will stop the loop, and then we're done. Okay? So that is the correct code to print from 1 to 10, unless I made some horrible mistake. And there it goes. Okay? Does everybody understand why this code prints these numbers? All right. How could I do this in reverse? What if I wanted to print from 10 to 1? What would I have to do? What would I have to change? Do we have any ideas? Like, what would have to change about this code? So I want to print 10 first, for example. 10, then 9, then 8, then 1. What would I repeatedly have to do? Interesting. If I wanted to print 10 first, what would my I's initial value have to be, first of all? I'd have to start it at 10, right? So that's a new thing. I'd have to start I at the first value, but the first value is now the big one. Now it's 10. And then I want to repeatedly print I, because that'll print the 10. And then how do I set it up to print 9 the next time? Instead of incrementing, I have to decrement. Decrement I. Interesting, because that'll make it 9, then 8, then 7, blah, blah, blah. All the way to 1, we still want to print 1, and then decrementing it one more time will make it 0, and we want to stop the loop before that 0 gets printed, because we only wanted to print from 10 to 1, right? So we want to keep printing while what involving I is true. What are our ideas? We want it to be true until we get to 0, right? What statement is a good one? I want to print while I blank blank. That would work. If we follow this pattern that we were using before, that's essentially the answer. We wanted to stop once I got too large, right? So we want I to stay small. We wanted it to stay less than or equal to 10. When we're going the opposite direction, we kind of want I to stay large and not get too small. That's the idea. That's kind of like the flip-flop. So we would like I to stay, you could totally say greater than 0, but if you want to follow along with what we were doing with the equals sign, we'd say the last number that we want to stop at is 1, right? Something involving 1. We want it to stay greater than or equal to 1. Okay? So everyone see why that's the correct condition? It can't be less than or equal to 1 because 10 would just stop the loop immediately. 10 is not less than or equal to 1, right? It has to be greater than or equal to. It's the opposite direction for that sign. Okay? Does that make enough sense? Any questions about how we determined that? So that's how you can print in reverse. Same pattern. So I is 10. While I is greater than or equal to 1, print I, and then we'll decrement I. I equals I minus 1. Okay? So let's have like a, let's print a line in between these. And so that prints from 1 to 10, and then also from 10 to 1. Yay. So notice the similarities. Okay? Starting value, some condition involving the ending value. That's how you do it. So, yeah, if we're still okay, let's keep trucking. So, let's talk about summing the numbers from 1 to 10. We did that in Scratch, right? How do we need to go about things in order to do that in Python now? So remember what we had to do in Scratch. We had to have a variable that kept track of the sum so far. And eventually we'll get to the end, and that will be the correct value. But as I is moving, we can keep that totally. We can be like I starts at 1, 2, 3, all of those numbers. That's still fine. We have to have a sum variable as well that starts at 0, so we can keep adding those values of I into sum, right? Sum is 1 now. Increment I, add the 2 now into sum. Sum is now 3, make I 3, make it 6. Keep on adding those numbers from I into sum. And then eventually, once you get to 10, add the 10 in. I think the sum is supposed to be 55, right? And then once it's 11, you stop the loop. So it's always that kind of addition into an extra variable. Do we remember that strategy? Let's take a look at how to do that now. Because we can steal our print from 1 to 10 loop and just do some extra stuff, can't we? We can totally do it like this. Loops. Let me section this off again. So this loop is nice because I goes from 1 to 10. Technically, I could use the other one too. We still get all the correct ranges of values. Inside of this loop, I has a chance being 1, 2, all the way to 10. That's perfect. It's just instead of printing, what do I need to do? I need to save, right? I need to add the current value of I, because the loop is going to iterate through the values of I that I care about summing together. Add the current value of I to my sum variable. And my sum variable needs to start at 0. Okay? So sum equals whatever it used to be plus I. That's what we do instead of printing. And so slowly but surely, I'll get added, sum will get 1 added into it, then 2 added into it, then 3 added into it as the loop progresses and iterates through its body and does it 10 times, right? Sum equals sum plus 1, sum equals sum plus 2, sum equals sum plus 3. That's what's going to happen because I is going to range over those values. And then the very last time, it'll say sum equals sum plus 10 because I holds 10. And then I gets to be 11, and we stop the loop. So once the loop is finished, sum holds the correct value. All the way to 10. I guess I should use the plus sign, right? Plus. That's the sum we're caring about here. Okay. That's the idea. So does it make sense to us why when the loop finishes, sum holds the right answer? Any questions about that? If I remember correctly, the answer is supposed to be 55. Cool. So that's the sum of all the numbers from 1 to 10. So we try them all. I get the chance at being all of the ones we care about. And we keep adding them into the sum variable, which starts at 0. And then once the loop has added all the numbers in, we're good to go. We have the correct sum sitting in our variable. All right, any questions about that before I move on to a different example? Okay, I'd like to bring together now, like, lists and loops. There's a reason I taught you lists in this lecture too. It's very common to want to, like, have a list that you got from somewhere and to go through each element of it. I want to visit every element of that list so I can do something with it, okay? So let's remember how to access our lists. So if this was our list X, remember that the indices are 0, 1, 2, 3, and 4. So the first index is 0. The first index is always 0, regardless of the list you have, right? Indices never change. They always start at 0. The last index depends on the length of the list, yes? So if we want to visit every index in the list, we have to go through x of 0, x of 1, x of 2, x of 3, and x of 4. The question is, how do we know when to stop? Where's the biggest list? Where's the biggest index in the list? What's the last one? And here is a nice trick to remember the last index of the list. It's always the length, which is 5, minus 1. The last valid index of the list is always its length minus 1. So do you see where I'm going with this? We can use an I variable, use some kind of iteration variable, to start at 0 and increment up to 4, and we can visit the list at each of those indices. Every single one, okay? So let me show you how to print a list with a while loop now. Here's what we can do. We say I is 0, start I at 0, and then we want I to continue while I is less than or equal to, what's the last valid index of the list? This one. While I is less than or equal to the length of the list minus 1, then do stuff. Do stuff involving x at index I. Is that a question? Does that make sense? I equals I plus 1. This will allow I to range between 0 and the last index of the list, and you can access that index with some expression involving this, where x is the name of the list and I is the index we care about. So each time the x hit the body, you're getting the next element of the list out. You can do stuff with it. You can print it, you can sum all the values. Does this idea make enough sense to us? So I have an example for, let's just print a list with a while loop. All the elements, one by one. All right, let's give it a try. Where did I want to be? Let's just keep on. Let's keep everything in this file, why not? One place that you can go and study. So let's make a list. Let's call it L this time. Let's be like, I don't know, 5, 6, 7, 8, 9. Doesn't have to be in order. Let's put 1 at the end. Okay, so that's my list, but it could have been anything. It could be arbitrary. I don't care how big it is. I'm going to make a loop that always works for any list. Okay? Because we're not going to hard code the last index. We're going to calculate the last index based on the list we have at hand. Okay? So I'll say something like, start my I at 1, I'm sorry, I at 0, that's the first index of the list. 0 is the first index of every list. And then I'm going to continue, I want to iterate while I is less than or equal to len of L minus 1. Because len of L minus 1 is the last index of every list. Yeah? And then a colon tab over. Let me put it all on the same page for you. There we go. And now we want to do stuff with L of I. And then we always want to increment our I variable because that'll set us up for visiting the next index in the next iteration of the loop body. That's the terminology. Okay, so the thing that we want to do, I guess, in my example, is to print the list. Let's just print the list out. We can say print L of I. That's the current element that I'm looking at. Because I will start at 0, that's the first element. I of 0, or L of 0, L of 1, L of 2. Those are all the indices that exist that we care about. Okay, so it'll go through all the indices of L in order, stopping at the last one, regardless of the size of the list, and get ready to go to the next one. So this prints every element in order, and it works for any list. I didn't hard code anything. I can make another value here. I can add 13 to the end, and it's still going to work just fine, right? Because it worries about, okay, what's the last element? It's always involving len. Okay? What's the length of the list? So do we see why this code is going to print all the elements of the list in order? Yeah? Please yell at me if you have any questions, because I have one last example. Okay. Let's bring it all together now. So, dun dun dun. It was really ugly for me to copy and paste code last time we were programming, right? Where I was drawing like 5 random squares of random sizes with random colors. Or I guess it was all just the same color. The color we cared about asking the user for. Let's do it a bit differently. Let's make random colors and still a bunch of squares of random sizes, but we're going to draw 50 of them this time. Okay? So the way that we can do this, I'll show you how, but the way that we can draw 50 squares very easily is to just loop 50 times and draw a single square in the body. Does that make sense? So we just put all our square drawing code in the body of a loop and have that loop run its body 50 times. Nice, not a lot of duplicated code. The loop does the duplicated work for us, which is quite nice. So that's where I want to go with this. So let's make a new phone. I don't know. Random squares.py. And let me steal the code from last time. Let's see if it's in this list. Oh, yeah. So I'm going to copy and paste all of this. Copy. Paste. So here's our code from last time that was drawing a bunch of random squares, 5 of them, of a color that we asked the user for. So let's get rid of that color for a second. Let's just be like, I don't know, turtle.fill color blue or something. Let's hard code that for now. And that this code in between these number sign comments is drawing a single random square. So let's just draw a single one right now and work our way towards 50 of them. Okay? So here is code that will draw a single random blue square. Do we remember how this works? Like we pick the starting point to draw our square, we pick the starting size of every side of that square. We go to that starting point, that was random, and then we moved according to the side length that we randomly picked. So that'll draw single random blue square, rerun it, it's random, so it'll draw a different square of a different size. Okay? So first, let's loop this. Let's print 50 squares, because why not? Loop 50 times using an iteration variable. So if I want to do something 50 times, it's really not that bad, right? I can just say I equals 1 while I is less than or equal to 50, right? Do some stuff, and then I equals I plus 1. Do we understand how this loop is going to iterate and loop through its body exactly 50 times? Because that I variable is going to be 1, 2, 3, all the way to 50. That's 50 different numbers. I'm just not going to care about using I for anything but counting how many times I want to do this thing. So that's all I'm going to use I for here. But this is a loop that will run 50 times. So I'll just put this code in the loop, and it will run 50 times. So draw a single random square. And remember to indent and then we want to increment I, so that we do it exactly 50 times. Okay? And then let's make the turtle very fast. Turtle.speed, I think it was fastest. That makes him go fast. And so this should work, and I gets a chance at being 1, 2, all the way to 50. So 50 times it'll run this code. It'll make 50 random squares. I don't think we have to watch it, but there it goes. That's beautiful, right? So that's some nice abstract art for us. And does it make sense why it's doing that? Why it's doing that kind of repetition? It's exactly what we were doing with text, but now with cool pictures. So that's the first thing that I wanted to show you. The second thing that I wanted to show you that we could do involves lists. So I would like to pick a random color as well for my random square that I would like to draw. Okay, here is a way to pick a random color. Let me show it to you. Dun, dun, dun. So instead of setting the fill color out here, let's set it every time we draw a square. Boop. Pick a random fill color. So instead of blue, it's going to be something else. So let's figure out what to put here. Here's one way to do it. I'm going to make a list of all the possible colors that I could pick. Colors equals a list of strings, right? Because you give fill color a string. That is the color name. Let's do red, orange, yellow, green, blue, purple. That is a list of colors, yes? How do I get a random fill color? How do I pick something randomly out of this list? That's my question now. So I need an index. Can I get a random index? An index is just a number. Oh man, random index equals, well, random.randint. I just give a starting value and an ending value, and it will give me a number back, right? What's the starting value? Like, I want a random index. I want all of these to be possible. So what's the lowest possible number that I want to get out of this random call? And what's the biggest possible number I want to get out of this random call? Do I want the number like -100 back from this right here? Because that's an invalid index, right? What are the valid indices? That's the main question here. They start at 0, right? Let's just pretend we're not going to care about the negative ones. So I want a random number between 0 and 0, 1, 2, 3, 4, and 5, right? A random number between 0 and 5. Yes? If I added a bunch of colors, I don't have to count, right? What's the last index of any list? The length of that list minus 1. So this number, this random number, is always going to be a valid index of that list. Isn't that cool? So this will give me back in this variable, a random number between 0 and the length of the list minus 1, which are all the possible indices of that list, 0 through 5, right? And so sometimes I'll get 0, sometimes I'll get 2, sometimes I'll get 4. All those numbers are possible. It's random. And I'm going to set the fill color to the colors at that random index. That'll pick out that random color. Any questions about these 3 lines? They have a lot of ideas involved in them. So here are all the colors I want to choose from. Let's get a random number that is a valid index in this colors list. That's the second line. And then let's set the color of the turtle when it draws its shapes to be that go into the list called colors at that random index and pick out the string that we just randomly picked. Okay? Pick out the string at that index, and that will be a random color. Is that, are we following all of that? Because drum roll, please. Let's see some very cool pictures now. 50 random squares, random colors, random sizes, random locations. Isn't that fun? So do we all understand what's going on here? So we're looping 50 times. I at 1, I is less than 50, I plus plus, or I equals I plus 1. Sorry. We're picking a random color, picking some random locations and lengths for our square, and drawing that square using begin and end fill. And it's random, so you rerun it, and it draws a pretty picture in a different way. So that's fun to think about and to watch. All right. I think that's everything that I wanted to say. Any last questions about this code or what it's doing? All right. In that case, I think we are at the end of class then. So please take the rest of time to do work on whatever you want to work on, and I'll be here to answer your questions. No new programming assignment this week. It'll be next week.